BlockMesh Utility, how is it work and how is it work in OpenFOAM. And basically this utility, this BlockMesh utility, it is used to create the meshing of an object. This BlockMesh utility it is used to create the meshing of an object. If you compare with BlockMesh utility, it is used to create the meshing of an object. Yeah, sort it out. So today, so we will see how we can create a geometry of a meshing of an object. Like here today demonstration, I have considered a one band pipe here today. So we will discuss in more detail in the later on. So I will explain each steps how we can create a basically this utility. We can create a small simple geometry mesh, and complex mesh is based on is basically based on your skill, how expert you are using this utility. So yeah, let's start in more detail. Yeah. So basically, like I said, the block mesh, basically this utility used to create the meshing of an object. You can see in this object, you can see in this here. So basically this mesh, block mesh, like we have seen, this name is block mesh. Basically it follow the block approach. Basically when we have the more complex more complex object, so we can break that that object into several blocks, sub blocks. So basically this is the for the reference case. If I'll explain this one later on. So just a little explain. Basically when we have the reference frame of here, so then when we have considered the one small cube here, so small cube, like so then how we can create the block. Basically it has first we have to create the vertices, like 0 1 2 0 1 2 3 4 5 6. These are the vertices, and we have the edges here, the edges like 0 1. This is the edge 0 1 1 2. These are the edges of the block, and its block, it having the face. Basically face is defined is mentioned here f0 f1. Basically face f0 f1. F0 when we have the x direction, then we have the one face, and this is the second face. So this is the x direction. Then we have the face number which is mentioned here, f0 and f1. And similar way we have the two faces in the by axis, right? So then we have the by axis like here and here. Face number is represented by this direction. So then we have two faces in the y direction, f2 and f3. Then similarly we have the two faces, one bottom base, like this down face and upper face. Like in the z direction we have two faces which we call here f4 f5. Basically this is the block which this approach we have follow when we use this block mesh utility. So I will demonstrate in more detail later on. First I will explain the summary. I will explain the summary what I'm going to discuss here today is here. So, and like I'm going to I have considered one problem to demonstrate this case of flow through in band pipe. Here I'll use this icoform solver. Basically this solver you to use for the unsteady state and uncompressible flow. So we'll see in the later on the more detail. So as I earlier I talk about the block mesh. What is the block mesh here? So, and first I I'll consider consider one tutorial case which is there are so many tutorial are in the source code of OpenFOAM, which is the tutorial folder. So like I said, we are going to discuss today is band pipe. So then we can consider I have copy one case like elbow. Basically this is the elbow, similar kind of thing, elbow. Yeah. So then we can copy this this elbow tutorial case from the source code of in OpenFOAM to the our current directory, where like if you type this cd dollar form underscore run, so then it will take you the run directory. So I'll explain the later. So and after that, if you copy this tutorial, then we have then we can rename it rename this tutorial in based on our what we are going to. So basically like MB, the follow all most of the people know the how we can change the name and or create the directory and all, and copy and paste all the things. Almost I hope everyone knows a little bit this. So when we have the beginners, so then before the beginners, so like how we can change the name of the this tutorial case. So like MB just told MB this is this, and we are going to new name of this. So then the case band pipe is based on your user specific whatever you call. I call the band pipe here. So then cd basically to take you the case directory here. So then these are the only the two commands we have to execute it here. So BlockMesh, which will create the meshing of the object, and this is the solver. Then after that we have to solve the equation, like we are going to solve the flow equations by this solver. Like only that we are going to solve here the pressure and velocity in the After that we have done this and we have the simulation result, then we have to visualize the results. Basically results is based on basically user specific, what user want to look into that, like velocity and velocity profile in the objects in the in band pipe, what kind of velocity distribution in the band pipe. So basically this is user specified. So now this is the basically in this here I have mentioned all the things what we have to follow here. For basically this I have mentioned the all stepwise for the beginners. So if they want to explore the things, so like cd we can go to the render, we can go to this our case directory which we are going to solve. Basically this is the our case name is the band pipe here. So after that if you have some if you want to explore what are the options available when we use this BlockMesh utility, so these are the you can type this BlockMesh -help, so you will get the some information. And when we have all the thing, when you have set up the thing, then you can execute it. You can execute BlockMesh, it will create the mesh, or you can create or you can use this this like BlockMesh greater than sign and logMesh. Basically whatever iteration whatever thing happen when we use it, it will store in this file. So and after that if you want to see these are the paraform block hyphen block. If you execute this command, so it will show the block what are the block of your object. And after that if you created the geometry of the mesh, then you have to simulate and you can run the solver. Basically this is a standard procedure in all. If you see the old tutorial folder case, then there are two scripts are there. So one is the all run and one clean. Basically one clean script, it will clean your run or your case. Whatever happens, it will clean your case. And another script, the all run. So all run, whatever command you are executing, so all the commands are mentioned in the all runs. Basically that is the standard tutorial format. So these are the, so if you are basically this, that is the, if you run that if you use that all run all clean, basically that we call that is the you are using the scripting scripting mode. And when you typed all the commands, that we call the interactive bay. There are two way. One is the scripting bay, another is the interactive bay. Interactive bay, in interactive bay or interactive mode, we have to press all the command. We have to give the all the command in the terminal which we are going to use it. So and if at the paraform, it will your case, it will open the basically this is the standard case. Yeah, this is not big deal. If you type paraform, it will open the paraform, para view, all the result you can visualize. After the if you want to execute paraform minus test, it will create this file, whatever case name plus home for. After it will create this file, then this file you can use, you can open with the help of the paraview command. So you can type paraview and that file name which is created here, so then you can open this thing. Now the basically, now what is the problem here? Just basically we are going to create the mesh of this band pipe. Basically this is the band pipe, this is the pipe. Basically it has the 20 mm diameter of this pipe, and this is the like if suppose this is a band, then there is a some yeah. So this we are going to mesh with this by using this BlockMesh utility. So yeah, now we will see in I will explain this a little bit. Just give me a 1 minute moment, just 1 second. Just this, like we have this pipe here, then we have this inlet here, and we have the out just 1 second. This we have the outlet here, outlet, basically outlet, this outlet here. So and this pipe we can as I said earlier, this blocking mesh utility, it is work as a blocking approach. So then we can divide this pipe into the several blocks. Yeah, we can divide this several block. So let me just 1 second. Yeah, so like I have mentioned here, like this pipe, well this is the outlet, basically this outlet, this inlet, and it has three boundaries. One is the pipe wall and inlet and outlet. Basically inlet, we are going to the boundary condition, velocity boundary condition. Basically what is the velocity, where here we have like I say, the dimension of the pipe is 20 mm diameter, and we have the velocity is 1 meter per second, 1 meter per second, and then there is a outlet, it's a atmospheric condition. So these are the three boundary condition we have here. So like I mentioned the inlet and outlet, just 1 second, this one. Yeah, this is the outlet. Basically this is the outlet, this is inlet, and this inlet we can divide into the several block. Like I mentioned, I always said that this pipe, band pipe, we can divide into various blocks. So I have divided this band pipe into 5 block. Like I have created a small square inside the pipe, and then we have the this one, these are the 1 2 3. Yeah, these are the like we have 1 2 3 4 5 faces. If these are the 5 faces, if you extrude these 5 faces into this along this band radius, basically this is a band radius. If you execute the band radius, then you will get the blocks. These are the 5 faces. Then if you extrude this in the band in this band radius direction, so then you will get the 5 blocks, like this block, this block, this block, and this block, which is showing in this graph here. Like I said, this one is corresponding to internal block, then it has the is there the 4 more block, 1 2, these blocks are interconnected. Yeah, so let me just 1 second. Yeah, this one. Yes, where is that? Yes, where is that? 1 second. Yeah, so like if you see the inlet, basically this is the inlet, this inlet basically see the this pipe, that is the outlet, this is the outlet. Basically I have plotted for the explanation, for the explanation purpose I made this separately, these two. This is the outlet, this is the outlet. Outlet, basically outlet, it has in the z biplane. Basically x is the this direction, that is the normal to the x basically flow is going out from the x direction, and the this is the by, this is a by and z, by z plane. So that is the outlet of this pipe. And similar way we have the inlet. Inlet, basically inlet, what is in that? Basically that is the, this is the normal, it's the negative y, that is the negative y, this is the normal. But that plane which is the inlet, that plane is the zx, so that is the zx plane. So that's what I'm explain, I draw in the I draw in separate figure. So then and this is very it will, it can be understand easily. So and if you see this block, then this is the block which basically this, the block is excluding in this band radius. So then if you exclude, then it will create this block. Yeah, this block. So after that a similar way we have the zero there is a one more figure here. Where is that? Yes, here this one. So like we have the five block here, zero block, b0, b1, b2, b5 blocks. So see, these are the five blocks. So and these blocks are interconnected. This is the block, these are block are interconnected, and we can see this in this figure. So then basically this is showing the block, but basically when we have the proper so then it will create the mesh like that, basically band of the mesh. So now I'll see the what I have done here. So basically what is the main advantage of when I have scripting in this script? Basically I have written this script in when we I use for this BlockMesh. So I have calculated the inlet, all the points. Just only we have to define the this one diameter of the pipe, and all the rest of the things you don't need to change anything. Just you have to define the and this one this diameter of the pipe. Based on diameter, it will calculate all the points, whatever points and radius. So based on this diameter, all the points, and it will calculate here in this script. In basically, yeah, like we have the like just one second, this yes, like we have this the 4 points here. This is the 4.01 to 01 for these points. Basically this number is depend on the your user specific. You can, based on your convenient, you can give any number, but you have to follow the proper approach. So yeah, so these are like 4 point this 4 point, for example, therefore 014, then we can find out the point. Basically this angle, like for this, if you see this at 45 angle, so I defined the angle 45, this angle. So after that this angle I have divided, then I have converted this this angle in degree to convert into the radian. So after then I have calculated all the points here by this cal mode. If you use this calculating mode, yeah, has cal 0, basically it will calculate this these points. So all the points I have calculated. Basically we have here the like we have the 16 point here, 0 1 2 3 4 5 up to 15. We have the 16 point here. So then based on that we have the block like just one second, where's the blocking thing? Yes, this one, like we have the block here, like I said the zero block, this block that is excluded here. So block b naught, b1, I mentioned it, 0 1 2 3 4, block 0 1 2 3 4. These are the blocks. And blocks, how many division in the block we have? We have the number of, we have to assign the number of division in the x and y z direction. That direction we have defined it here. And yeah, and simple, this is the simple, I will use the simple candy, basically this one piece, basically that is the grade, you know that. If you don't know, I'll explain, because yeah. So basically that is standard format. So after that we have to, like I said, that we have to calculate. After that we have the this arc. Basically when we have the this like we can see, we have seen here this band. So basically this is the arc, and we have the this arc, and we have this inlet arc. So we have to define this, that's what, if you define this all the thing, how this arc is connected, and all the thing, and which point is connected. So based on that, it will create this whole geometry. So where is that file? Yes, here. No. Yeah, I have defined it, these all the things, which number, which point we have connected here, all the things. Then we have the 2 point, and basically these are the, suppose we, if we want to define the one arc, for example, if you want to join, if you want to zero, where, just 1 second, where is that, if you want to, connect this arc 0 3 basically here is the, suppose origin here, the band radius, then band radius, then we have to find the point, interpolating point, then we have the 0 1 2 point, we know already, then we have to define one more point, then we have to find out this point. Yeah, so this point, so like I have mentioned in this, point. So basically 0 3, this is a connecting point, and we have given the one interpolating point. So based on that, we have created this approach. So, and these are the arcs we have defined it here, and we have defined it in inlet and outlet and pipe wall. Basically pipe outside is the pipe wall, we have defined it the wall, pipe, basically it is the wall, pipe wall, and this is the inlet is a patch type. Basically outlet is a pressure outlet, and velocity inlet, patch type, type is patch, basically velocity. Here the wall basically when we have defined the which type of this wall mean, we have no slip condition here. So these are the approach. Basically what is this, what is the advantage of this, just you can write on your own, basically here only I need to define this diameter of the pipe. It will create all the required parameters, like all points or radius or band radius, it will create based on this. Yes, so that is the script, BlockMesh dict. So then yes, and I'll explain in the demonstration also, this one. This one, up to this, I hope it will be somewhat, you will get some. Yes, so after that, it is the result. So now I am going to demonstrate one case here, this simple case. Basically we can copy the case, we can copy what we are going to do. Just we have to OpenFOAM, like several OpenFOAM version are installed in my machine. I am using OpenFOAM 9 latest version, community version. So that's if you run this command, so it will take you the run directory. And another way, you have to press foam underscore run. This is the environmental variable. If you type, then it will the same way, it will take you the run directory, ls. Basically you can copy the directory, but I have already copied this this tutorial. I rename it band pipe name. So what are the inside in the here tree, you can visualize what are inside this. So you can see this is standard format. So we have the, when we have the case, when we have one initial initial zero directory and constant folder and system folder. Basically these are three directory is having. So zero means zero directory, it is having the initial flow field condition, what flow field condition, like velocity and pressure. So and constant folder, like it's already mesh is created. So already constant folder, it has basically it has a mesh information which is in the directory of the polymesh, and the transport properties. And the system folder, it had the control directory, control dicta, basically control, basically we can define the temperature and solver name and writing all the time delta t and so, and we have a finite volume scheme file, and another we have the finite volume solution. Here we have to set the some we have to give the some parameter values, you can see. And basically this is the standard format. So basically like all I have done already some. So what I am going to do for now, I am going to clean this tutorial first. What happened? Form 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 clean tutorial. Just one second, let me just one second. Tutorial, yeah, it will clean. Oh, what's happened? Control C. Oh, basically I did some mistake. I we go wrong place. Just one second. Just we have executed another wrong place. So there is something happened. Just we don't want this. So just we have to go run cd band 5 ls. So and here we have to clean this tutorial. It's already clean now. If you see this, if you see, then we don't have this that tutorial that for that polymers. So now if you want to see this what is inside this file, this is the same I have shown this file. So you can see, you can system and block. So then you will see this all the whatever I have showed you here in the BlockMesh. So all the information in this file. Now what just let me go out. So now just you have to press BlockMesh. So then it will it will create all the points like we have used the calculation mode. That's what all the information, and this is the dynamic, all the dynamic this is the basically all the parameter is calculating here. Yeah, so let's wait some time, because all the iteration is happening, because it's calculating all the point. Because yeah, because if you give the point values, then this you will not see, you can't see this thing. Just it will take the value and it will create your mesh. So first here what's happening, first is calculating the all the points. So it will take some time till that is happening. So based on that I'll explain this next like I have run this icoform. They basically this is the information, but I have given the one velocity 1 meter per second and diameter of 5 to 20 mm. And so based on that 20 you can calculate, and this is the basically mu air. So then we can calculate it. The Reynolds number is 2000 here, basically laminar flow. So this laminar flow, then we can execute this icoform solver. It will calculate at different time and save it. Basically I have shown here the two results for the two time step, like initially result. Initially we don't have anything here. So after the iteration happening, so as time evaluation, so then after some 0.06 seconds we can see the profile is developing, profile is changing, is velocity is changing in the pipe. Basically these are the slice I have shown, the one plane, this one, and basically this is the 3D. You can see the 3D basically 3D. Here the slice, this is a whole pipe, and we have the one plane, and plane we are able to see this velocity profile, see, and this one, and this is the 3D. Basically yeah, 3D we can see what happened in the inside. So that's what that is the better way to create the one plane. So then in one plane we can see this yeah. And let me show that it is this yeah, this block mesh. Yeah, that meshing is done. If you want to see how many mesh statics, so you can check, you can type check mesh utility. Yeah, yes. So it will give you, it will tell you the properties of the mesh basically. Yeah. And what kind of the mesh, and what kind of the cells in this of the in this object. So this is the basically hexadral hexahedral, all the mesh are yeah. Yeah, see, and these are 3,20,000 meshes here. So now I actually, and if you want to see what inside, just one second. No system. Yes, I'll show you zero folder and v 0. Yes. So, and as you can see, I have defined here the two three, we have three boundary condition: pipe, inlet, outlet. Zero, yeah, outlet, we have defined the velocity in the bidirection, basically. Like this is the pipe, so we are going to pass the velocity in the bipositive. So then we have defined in one. So yes, a similar way you can see this similar. Yeah. So, and I have set all the things, and if you run this, so you have to press icoform solver. If you want to save the all the iteration in the file, and just you can type whatever you want to give the name, you can give. So, and if you, I'm just typing this one, it will show all the iteration in the terminal here. So like see iteration is happening, the simulation is started now. So like initial time step, we have given this delta t is given 0.1 second. So based on that it will create. So meanwhile, actually I have done this. I have already simulate. I have done for some simulation in the case. So let me show another window. Just let me ls cd 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 just case band. Yeah. Yes. If you want to see the block here, so let me see big like I said, para foam minus block. So yeah, it's something because I have not I have not compiled the third party like para view is here. So based on we can use the some another fully compiled OpenFOAM version there. So yeah, now I have using the developing OpenFOAM developing version. So I have assigned this one. Now you can see the block. Yeah, you can see, like I mentioned, that you can see the block here. So these are block. If you want to switch all the curve, then you can see the block are here. This is the inlet and this is the outlet. So these are the 5 blocks, and if you want to see there's the arc, then this is of the block, and this arc, basically this is the pipe all the arc basically this is the radius, this is the band radius we don't, and this is the inlet, this is the outlet. Basically we have the 8 arc here and 4 arc here, inlet, 4 arc here. So that's what it's showing, the 8 arc, and it will show the number how this like I earlier I told 0 to 3, 0 to 3, it will mention here 0 to 3, 0 to 3, all the information is here. So you can see all the blocking here. Now it's done. Now I'll explain the another thing. Just para foam open foam parafoam Yo, because I have not compiled parafoam, we have to give this this option. So because I have already created it here, we can just upload we can load this. So what happened? Something, oh, actually I have not assigned that I have not assigned that file. Just one second. Just disconnect. Yeah, then we can load here, load it here, state here. Then we have to give the that directory, specified directory, because yes, yes, something is wrong here with this. Just let me just, we can create a new one. Just we can type here. What happened? I don't know. Oh, yes, I know what are the problem, because we have executed, we have to show on this block thing, right? So that's what this something is a problem with the like here, some mess problem. Like, just one second. Let me see. Yeah, some problem here. So let me see this. Stop this one, and we can use this paraFOAM minus. Yeah, it will come now. Yeah, see, as you can see, this is the pipe. Basically this is the pipe, and if you want to see this is yeah, there is some iteration, iteration is happening still. So this is the, basically this is the pipe, and if you want to see the geometry of this, then you can see the geometry here. So this is the geometry. Yeah, and we have this one like 20 mm. Based on 20 mm, we can specify this in internal this block. You can just, I have mentioned the one factor, just you need to change that factor. Here is the 0.20 0.25 factor of this the radius of this pipe. Yeah, this is basically, this is the I have today. So I hope if you want if you want any help to create, if you are facing any problem to using this BlockMesh Utility, you can write to me. So then I can explain, uh, I can try to give some input, so then you can easily solve your problem. So these are the links, useful links, you can go through it. So thank you for watching today this Moses and Sansa.